Alright guys, let's do this way. Questions on the group work sheet.
Okay, so for A, it says verify the distribution and then show why it's valid. So how would I explain like the points having to be greater than 0 but less than? Is that what I just write? Instead of like
X is greater than 0 is less than X is less than 1. Oh, that's not really what?
Stop there. Step number 1 is to say, a lot of you guys said P of X equals 1. No, it don't. Nowhere in there does P of X equal 1. P of X is like 0.251 and 0.352. So don't say P of X equals 1 when it's not true. What about the P of X is 1? The sum. Or you can say in English if you want to. Right? Math is my first language, but I can read English. This is nice. The quickest way to say that. The sum of the probabilities is 1. Or the sum is approximately 1. If it's 0.999, don't tell me it ain't valid. That's freaking 1. Leave me alone. It's just, it was rounded, right? They cut off some of the last decimal points, and it's just rounded. Not a big deal. And the reason I say that is because I will tell you this now. People will still write 1. On the test, it will not add up to be 1. It'll be like 1.0001 or 0.9999993 or something. I want to see that so I know that you actually checked it. So if I say verify this, it actually means go and do it. Don't just state it. So these are the things that have to happen. You go and check and make sure they happen. And the second thing is, what's got to be true about all these? They have to be between. So that's how you say between in math. Or you just, again, if you want to say it in English, you can say each. So this is the English translation. Each probability is between 0 and 1. Or you can say they all add up, all the probabilities add up to be 1. Don't say all the values add to 1. What values? There's a lot of values there. And these are almost too easy to believe. That's all you got to say. And of course those are true. We know they can't be negative probabilities or more than 100%. That's what that guy said. And we know that they have to add up to be 1 or close to 1 in case they were rounded. Like in the days of our histogram. It didn't always add up to 100%, but it was always close. Maybe we rounded a bit. All right, how are we doing there? Is that cool? So that's the first question. Let me see, what else went freaky? Most everybody got 1B okay. Some of us didn't round correctly. Again, how many places at least? Standard deviation? 3. 4 is great. That's at least 3. So when in doubt, go 4, because that's the most I've ever said, right? Probabilities, you normally go out 4 places, because that's how many are on the chart. So when you're like, how many did he say? Just go 4. That covers your ass in every direction. Now z-scores, how far should you go for them? Why 2? Because the chart's only got 2. That kind of makes sense. I like it. Okay. All right. What other questions we got? 2A, that problem like 2A. And the homework, I have to see the formula work. I know there's a binomial PDF. I showed it to you. But I said you could use it to check your work, right? I personally like to teach it where you can see what goes into the number. Not just have a number come spitting out at you and you're like, well, there's the number. Let me write the number down. I want you to see what goes into creating that number. What math went in to making that number, right? So that was this dude. Like 22, choose 11, P to the 11, Q to the 11. This is the part that always looks weird, but it's just the rest. If there are 30 total and you want 9 successes, how many are left over for failures? 21. This is the rest. I like it. Anybody, any other questions from the group work sheet? Oh. Anybody else not get theirs back? Oh, yeah. Here. Mhm. Delivery. All right. So everybody got theirs back? Just make sure you understand. I told you this is going to be part of your homework grade, so it's going to be worth roughly like half a quiz, because the quiz and homework average is one big average. But just so you know, it's going to be worth roughly half a quiz. Some of you guys wish it was worth more. Some of you guys wish it was worth nothing. But this is funny as always. Everyone wants me to have an open book, open notes, open people, and that's what I did. And some of us still are 50s. Yes?
So can we do corrections of these for the homework?
No, this one I won't let you do corrections. Just because it didn't count for much. I graded it really nice, to be honest. They gave you a big cushion. I didn't take off as many points as I could have. So this is just it. I don't feel like regrading them all. Everybody understands the max and min usual values? I mean, if you think about it, so guys, if you think about it, it sort of makes sense. If I normally make 80% of my free throws or whatever, then I should, if I take 20, I should take somewhere close to 16 should be made, right? So if I'm way far away from that, that would be unusual. So the idea of unusual in statistics is the same ideas of unusual in the real world. If you're far away from what you expect to see or to have happen, we call that unusual. So visually, if I'm in the mean, and I get anything more than this or anything less than this, right? Those are your formulas for that. So everything inside here is what we call usual. And anything outside of there is freaking unusual. So if an average height of a man, and I saw somebody who's this tall, I might do a double take because it's not something I see every day, or even over there. If I see somebody 7'8" tall, I might, what? Because it's unusual. It's not what I expect. That's why we call that the expected value. I expect to be close to that. All right, maybe. Yes. Siri, how do I get her? All right. All right. Anything else in that group worksheet? How was the rest of it? Okay, so let's do this. Let's do the formula sheet. And what you can do is you can bring in all of your formula sheets with you. You probably want to redo any that you lost points on. I've had people use the same exact one. And I just said, okay, the same points come off again. So don't do that. Don't do that, please. Restore my faith in humanity. Yes?
Can we, rewrite
Oh, yeah.
one formula sheet onto the silver
Sure.
page?
Yeah. Every formula that's on any formula sheet we use in here, you can use for the final exam. So if you want to keep making a new one that has all the formulas we've done so far that I allowed you to have, beautiful. I love it. Or just bring them all in. Bring a stack, I don't care. One formula on each page. Or whatever. As long as it doesn't bother people around you, I don't care. So here we go. This test starts in chapter 4, right after the probability section. So chapter 4 is where we got into the x, p of x stuff, the binomial probability stuff. So that's this stuff here. What's this the formula for? For the mean. I like it. Expected value is another name for the mean, and the first 3 letters in that is freaking expect. Expect. That's crazy. That doesn't happen often enough in math. And then the variance for x, p of x stuff. Again, this is the one that's very difficult to see the concept behind it, but don't write this down. Just came from this. Which, if you remember, this is the original formula for the variance, right? That's the original formula for the variance. P has N on the bottom, so these are actually the same stupid formula, right? I don't know if you guys see that. P has N on the bottom of it, so these are the same. And if I FOIL this out and bring that in and do some stuff, it becomes this. And this is just what I call a calculation formula. This is a conceptual formula. I can see the concept here. How far is each data point from the mean? That's the basic idea of a standard deviation, right? The average distance, blah, blah, blah. This loses that, but it's easier to work with in the tables. You just need one more table for this. One more column, sorry. All right, let me stop there for a second. So don't write this stuff here. All right. Then we had the binomial stuff. We had this here. Draw a line if you want to. We had the mean for it. Standard deviation for it. Please notice that's a variance, right? So if you want to, up here you could write sigma equals square root. You guys see that? If you want to. I like it. Let me see if I can get you guys to understand this next thing I'm about to say. I'm not going to have any questions on the test about the geometric distribution. You still have to do it for homework. If you don't understand that, that's too bad. Don't do it, it's too bad, it'll hurt you. So I still want you to know the geometric distributions out there. It's used for when's the next earthquake going to hit, those kind of problems. And it looks a lot like this. It uses this idea, actually. But I'm not going to put it on the test. I just want to see if you guys can plug and chug in the formulas and stuff. So you don't have to worry about putting geometric stuff up here. Then we got into continuous variables. We have the uniform distribution. Now, the uniform distribution has this mean. If you've done the homework, hopefully you've had to use that formula somewhere. And then it has this weird-ass and one semester I actually showed people where that formula came from, and they said, I wish you had never shown us that. So it's like I said I wasn't going to show it to you. They're all freaked out about the 12, but if you do the work, it actually comes out. But this, you had to use it in a couple places in a later chapter to figure out the standard deviation of a uniform distribution. All right. So you can put those down if you want to. Let me see. Then we get in, yes?
We don't need those, right?
No.
So we should have put them on.
I would say no. All right. I love you guys. So, why is everything you ever do in a math class in homework always is everything on the test? No, because that would be impossible. The test would be amazing. It would be, each test would be a week-long experience. There's a lot of stuff in the homework, and the reason I assign the homework is so that you could experience using it. These formulas are not used very often, but I want you to know they exist. So, because what I said before was every time they give us a different way that they give us data, there has to be some new way to calculate the mean and the standard deviation. So they give me a uniform distribution, there still must be a mean, there still must be a standard deviation, and these are the ways you would use to calculate them. And one reason I don't really spend much time on this is because the derivation of this is not pretty, and it's a little bit beyond what we need to do. But I still want you to be able to just plug and chug into this thing, right? So, okay. Where am I at? Oh, so then we get to normal distribution. We have this guy here. And this has actually been on some earlier ones. So you can put that one if you want to.
Which one is that for?
Say again?
What is it? What is that for again? The one they just read.
What letter is that? Cool, I like it. So this is one formula that actually tells you what the hell it's for. It's the z-score. I like it. Cool. You guys are looking like it's weird. What's happening? All right. So tell me this in words. What does this say in words? What's that? That's X, sure. Data point. Minus the mean. And this is the mean of a what? Population divided by. So I would use this formula if I had a population. If you want to write down what it would look like if it was a sample, what's the sample mean look like? What's the sample standard deviation look like? what I really want you to realize is those are not different formulas. It's x minus whatever the hell the middle is, divided by whatever the hell the spread is. That's what it is. Yes. Yes. So I know that a lot of you guys believe that math is formulas and plugging shit in. That is not math. That is like the piddly little last business. Math is, what is this formula about? Why does it make sense? Where did it come from? How did we create it? What was our purpose in creating it? That's math, right? You're like, what the hell's your point in this? Well, the same idea is behind both of these. It's the idea that's important. How far do I go divided by how big each step is? Tells me how many steps there are between those two things. Let's see what else we have. Oh, then we got to here. Now, you better look that up, because I get all kinds of weird shit written down here from what you guys see me write. What is this? This is sigma. What is this? And what is that thing that's here? What do you call that in general, the thing that I put there? Subscript. It's not sigma over x. That's what some people see, and those are the people that I know don't understand the idea behind what we're doing. This is the standard deviation for sample means of size n, right? If I take a sample of size n, how spread out are the sample means? That's what that means. In order to do well in a class like statistics, the math is actually not the problem. The computation, calculation stuff should be relatively easy. What's the easiest part of algebra? I'll tell you what x and a and b are. You plug them in and you calculate it. That's the beautiful part of algebra, right? That's what this is. The hard part is the idea. You gotta really dig into the idea. So when do I do this? When I take a sample and I ask about the sample mean, that's when I do this. Because this standard deviation is good for what types of things? This here. What's this standard deviation for? Individuals. And what's this standard deviation for? Groups of size n. Okay, maybe. Maybe. All right. Let me see. Anything else that I've forgotten that needs to be up there? Any other suggestions on formulas? Oh, if you want to, you can write this. Right? This is for if I don't know the z-score. I got to make an x-score into a z-score. This is if I have a z-score that I want to make back into an x-score. So this is when I ask you, find the score that's the top 5%. Well, then you can look up the z-score in the chart, but now I want you to convert it back to a test score or whatever it was. Okay. I like when it's such quizzical features and all we're doing is making a formula sheet. That's a good start. All right. So now let's get into whatever you want to get into. We get into the practice test. I want to do the last problem on the practice test because it's not on the answer key. So we'll do that number 6, I think it is, together. So everybody got everything up there that they want? More than you wanted? Aw. You signed up for it. Okay. So, number 6 on the practice test. How many of you guys know, and I don't mean the Casbah like the Casbah off in the Middle East. I'm talking about the Casbah downtown. How many of you guys know where the Casbah is? Anybody? The Casbah? It's a place to go listen to music, and you ever heard of it? I love it. You guys are all like, that's probably a place for old people. You're your old people, Jeff. So that's what this number 6 is all about. There's a place downtown. Huh? Your mom might know one? Is that what you said?
No.
Number 6 says, About 25% of Grossmont students know where to find the Casbah. If you select 20 Grossmont students, so right already, what kind of problem does this feel like it's going to be? Yeah, why is it pretty obvious that it's going to be a binomial probability? Because what's the 20 going to be? The 20 Grossmont students. That's n. And can I find a p and a q? Are there two possible outcomes? Either a student knows where it is, or they don't. So this is just yelling at you that it's a mu equals np, n choose x, p to the x, that kind of problem. It's an npx problem, npq problem. So what do I know so far? I know n is 20. I know p is what? 0.25. So q must be what? 0.75. So then I ask you, if you take 20 students, what's the probability that exactly one of them, and I'm sorry, exactly 6 of them know where it is? Now, this is not where you write binomial PDF. You basically tell me what buttons you pushed in your magic little box, and it spit the number at you. That's not what I want here. Taking the wrong teacher if you wanted that shit. I want to see the formula put together. The formula that actually has the idea of why this gives you the correct answer. So I desperately want someone out there. If I write it in this way, how many successes do I want? 6. So how many failures do I want? 14. But how many ways? Here's one way. There's the first 6 and the last 14. And then, so really, how long is this list? I got to add up each of these. That's the idea of this. And that's this first part is going to be 20, choose 6. That tells me how long this list would be. So the formula shows me the idea behind why it gives me the right answer. If you push buttons, the buttons don't say shit. This button looks just like that button. Button number. Yay. That ain't math. So I got 20, choose 6. P is 0.25. I want 6 of those, and I want the rest to be failures, 14 failures. All right. And this is not the time to sit there and grimace. This is the time to ask a question. If you're not sure where something came from. This is review day. This is the time to let it out. Say, I don't understand the first damn thing we did. Well, shit, let's start there. So how are we doing? Is this cool how this is set up? Almost, some of you guys don't believe me, but this is almost too nice to believe that this formula exists, because the idea of it's right there. I got 20 people, choose 6 of them, so I want 6 successes, the rest failures. That's the formula. You can read it in English. Holy shit. So now I just plug in the calculator. What do you guys get?
1,686.
What is it?
1,686.
1,686? Okay.
After we are done with this, can you do an example? I mean, I don't know, with the same problem or something that says at most something?
Oh, sure. There's the one, like 5(1)b. X less than 22, that would be at most 21. That's another way to word that one. So yeah.
Which one?
The one says probably X less than 22. So if I said at most 21, then that means less than 22.
Oh, okay.
So that's the conversion. It's just translating from the English to the math. Yeah. All right. What about part B here? Is everybody cool with this? And again, if you really want to, you can set the formula up and then do binomial PDF. I would never know. But if this don't match this, I ain't gonna like that. If you got the right number here and the wrong setup here, that's bad. That's bad. Let's see, part B. What's the right way to do this? I mean, what does this mean? Can somebody read this in English in terms of Casbah and students and stuff?
At least one.
There probably at least one student knows where the Casbah is. I like it. So how many ways is there to have at least one student out of 20? Well, one student can know where it is. Or 2, or 3, up to 20. So what's a good suggestion you do instead of what? I heard you say it. Come on. Yep. The only thing that this leaves out is 0. And since this plus that is 1, 1 minus that must be this. Some of you guys get that? So now, to calculate this, I just got to do this formula, but now I want 0 successes. So let's see, it would be 1 minus 20, choose 0, no successes. So I want none of these, and how many of these do I want? Oh, 20. 20 failures. We've done this kind of thing before. We have done this kind of thing before. And just to put it in a different format, how many successes can I have in this problem? 0 to 20, right? I really want you guys, some of you guys still look at me like I'm insane. If I add all these up, what will it be? 1. So then 1 minus these has to be this, don't it? 1 minus all these probabilities of these. So 1 minus this probability has to be these. So 1 minus the probability of 0 must be the rest of them. Because everything together makes 1. I mean, that's how that works. We've done this kind of thing before. So now, what's this by itself? 1 minus, what's this?
0.
Yeah, it should be 0, 0, something.
712.
Dissension. All right, let me see. Yeah, 0, 0, 3, 2. So 0.9968. Is that cool? And just to remind you guys, you don't have to know this. Some of you guys can latch onto this. Anything choose 0 is 1. There's only one way to not choose something, and that's just to not choose it. Right? So this is 1. Anything to the 0 power is 1. So all I have to put in the calculator really is 0.75 to the 20th power. And that's what that is. Okay, maybe. All right. Where am I at? Part C. This should be the easier part here. These are the most beautiful little equations we've had. So part C says, what's the mean in the standard deviation? Well, how do I find the mean? N times P. So it's 20 times 0.25. 1/4 of 20 is 5. So that's the mean. And the standard deviation is the square root of
5 times
NPQ. It's going to be just below 2, like 1.9. 1.9. 365. So 37.
936. 4.
Okay. 1.936. Okay. Now again, just to remind you guys, just make sure everybody's on the same page. I'm doing this one because I didn't put it on the key. The key has all the other ones on it for the most part. So there's the mean, there's the standard deviation. So how do I get the max and min usual? Yeah, take the mean, go how many steps up?
2.
So 8.87.
8.87. Yeah.
8.87. And then subtract, bam, bam. Like 1.13 something. Alright. So cool. So that's part D. So that's the min. And that's the max, usual value. So did I ask you? Yeah. Would it be unusual to find 11?
Yeah.
If I took 20 random gross monthly students, if I find 11 of them, that would be unusual. Does unusual mean impossible? No, it's completely possible. It's just not usual. It's not what I see normally. It's not impossible to get a 7'8" tall dude, but it is unlikely, unusual. Yes.
So if we already did that for B, then how do we? Because you put Y, so what do we want?
E. 11 unusual. More than 2 standard deviations above the mean. Outside the usual value, however you want to say it. You can even put it on this and say it's out here. It's an outlier. Yes. Did I do what? Sorry? I've got it right here.
Oh, you haven't given it up.
No. I have not. Alright guys. So I just want to do that one because that one's on the key. Where do we want to go from there? Yes.
I just had a question about homework. In 7.1, I think it was, or 7.2, it says like find P80 of the average. Do you just do, like, it was asking a lot about like P80 and P50 of the weighted average, and I was just, do you just do 80.8 times whatever small decimal you get as the...
Can you give me an example where that is?
Yeah. 64C, 64D.